Okay, this next lesson is going to start. We're going to start talking about binomial theorem and Pascal's triangle. Okay, then we're probably going to cover this over a couple of lessons. So what I want to talk about is drawing out Pascal's triangle. And what it is, the concept of Pascal's triangle is, and we'll work to stuff like this. If you had something of this nature, okay, which would be really hard to actually write out, okay, and foil that many times. A guy named Pascal came up with an idea of how to he came up with a triangle that would help you figure out both the numbers and the terms and all that kind of stuff. So let's talk about how you would draw Pascal's triangle. And what we want to do is we want to be able to draw this. You can see this on Google. You can look this up. I want to explain how it's done so in the future you can draw it yourself. So what I would like you to do, draw one square, and draw one square, and one square, okay? Now, what we're going to do is we're going to continue this pattern, okay, all right, where we draw a square outside, inside, and outside, okay? So outside of here, inside, outside. Let's continue that pattern. Outside, inside, inside, outside. Outside, inside, 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 outside. Inside, outside, inside, 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 okay? Outside, inside, 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 outside, outside, inside, 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 outside. Let's see what levels we have here, okay? 0, 1, 2, 3, 4, 5, 7. Oh, I wanted to get it all the way to 10. I think we'll get to 10, that's good. All right, so, all right, like Mr. Evans, I just watched a video of you drawing squares, okay? All right, now, let me explain how Pascal's triangle works, okay? All right, first of all, these are the different levels. 7, 8, 9, 10. That's all I'm gonna go up to, I'm not gonna do that last level. 0, 1, 2, 3, 4, 5, 6, 7. Oops. Unbelievable. Okay. Okay, so here's what basically this was. All right, if you do Pascal's triangle, you always start the top level 0, and it's going an exponent. Now what this stands for is, this is the exponent outside. Okay, this is the exponent outside. Okay, so 6 would be like this level, okay? Now, you start Pascal's triangle with a 1, a 1, and a 1, okay? All right? All right, now, here's the idea. This one number always down this side will always be 1. Okay? This number outside here will always be 1. Okay? Now, to figure out the numbers inside, what you do is I add these two boxes that connect to it together. So 1 plus 1 would be 2. Okay? Now, how would I get this box of the triangle? Use these two. 1 plus 2 would be 3. Okay, how would I get this one? Same thing. 1 plus 2 would be 3. Going down to this level. Now I'm using these two. 1 plus 3 would be 4. 3 plus 3 would be 6. 3 plus 1 would be 4. Okay? All right, I get this one from 1 and 4 would be 5. 6 and 4 would be 10. 6 and 4 would be 10. 4 and 1 would be 5. Okay, coming to this one, this would be 6. 10 plus 5 would be 15. 10 plus 10 would be 20. 10 plus 5 would be 15. 5 plus 1 would be 6. Okay, all right, this one, 1 plus 6 would be 7. 6 plus 15 would be 21. 15 plus 20 would be 35. 20 plus 15 would be 35. 16 plus 15 would, 6 plus 15 would be 21. 6 plus 1 would be 7. Okay, coming to this one, this would be 8. Okay, this would be 28. Okay, these two add up to 56. These two add up to 70. These two add up to 56. These two add up to 28. These two add up to 8. Okay, all right. These two add up to 9. These two add up to 36. These two add up to 84. Okay, these two will add up to 126. 126, 84, all right, 36. You add those two, you get 9. Last row will do. This will be 10. This will be 45 from adding those two. This will be 120. Okay, this would be 210. These two added together would be 252. These two added together would be 210. These would be 120. This would be 45. This would be 10. Okay, now a couple patterns you probably see. Going down the diagonals, it's just 1 through 10, going each way, okay? So if you want to fill that in at the beginning too, it actually makes Pascal's triangle really easy, okay? Is that if you could go 1s, 1 through 2, 1s, 1 all the way down to that, and then you got a lot less to do, okay? Now, what do these numbers mean? These numbers are the coefficients in front of the terms. Okay? And that is in a standard x plus y to a certain power, whatever that is. Okay? We're going to talk about how the number changes based off of you change the number on the inside. Okay? So what I want you to do, and I'm not going to go through it with you, I would like you to pause your video. I'm going to go to the next page. See if you can draw out Pascal's triangle. If you can, fantastic. Okay? So pause your video and go ahead and draw out Pascal's triangle, okay? Check to see if it matches. Okay, now I'm gonna have Pascal's triangle in my hand. I hope you have it on your notes, so I can't go back and reference it every time. All right, so the next thing we need to talk about with Pascal's triangle is understanding the different levels when it comes to the variables, okay? So let's start with a very simple concept of x plus y. All right, x plus y to a certain power. Doesn't matter the power, okay? We're going to talk about this, okay? All right. Power of 0, we're not going to really overly get into that, okay? All right, power of 0, just anything's going to be 1, okay? Now, when you have a power of 1, okay, here's what you have to understand, is that your x will start, the first term always starts with whatever the power is, and the second term, okay, starts with 0, okay? So you always start first, second, okay? And I'll explain it in a little bit. Now what the idea is that this next letter will drop down 1, and this letter goes up 1 as far as the exponent. Okay? How do you know you're done? Once the second letter reaches that same amount. Okay? So for 2, all right, it starts x squared, y 0, then it goes x1, y1, and then it goes x 0, y2. Okay? If you do 3, what does that mean? x3, y0. Next one, this goes down 1, this goes up 1. Next one is this goes down 1, this goes up 1. Okay, the next one is this goes down 1, and this goes up 1. And notice we know I'm done when I get the second letter, gets that second exponent. Okay, all right. Let's say random number. Let's say I had 5. What would that look like? Okay, x5, y0, x4, y1, x3, y2, x2, y3, x1, y4, and then x0, y5. Once again, how do I know that I'm done? I know that I'm done when the second term gets to that exponent, all right, from that standpoint. So what I would like you guys to do is try on your own the power of 7, okay? So go ahead and pause your video and go ahead and try the problem of 7. Okay, I just want to get this expansion, then we're going to tie the two things together. But having this is very important, okay? All right, so what would that look like? It would start x7, y0, then go x6, y1, then x5, y2, then x4, y3, then x3, y4, then x2, y5, then x1, y6, and then x0, y7. Okay? So that's what your expansion would look like. Okay? All right? So hopefully you get a little bit of an understanding of that. All right? Now, all right? Why does that make sense? Okay? All right? If you go back and you look at even, let's take a simple example like we've always done. All right? Let's say x plus y to the second power. Let's talk about that. Old school way of doing it, we do this, right? And we would FOIL, right? We would FOIL, so that's x squared plus xy plus y squared, right? And this would be x squared plus 2xy plus y squared. Okay? Now, let's go back to what we just write now. All right? So we say, well, Mr. Evans, what is y0? Well, y0 basically goes away, right? Because anything to a 0 power is 1. So that part goes away. Same thing with this x. So if you took out those, that would be x squared plus xy, okay? All right? Plus y squared. Now, so we say, Mr. Evans, there's a 2 there. That's fine. We're going to cover that in Pascal's part of it, okay? He figures out the numbers out front. But if you look at the exponents, that's x squared, xy, and y squared. Okay? All right? So, all right, how do you do these expansions? Okay? Let's talk about that. Okay? Let's talk about that. Let's say I have x plus y to the 4th power. Okay? Let's get into this. Let's actually expand it. All right? Now, there's 2 components to this. It's figuring out the Pascal's number part. Okay? It's figuring out the Pascal's coefficient part and figuring out the variables, okay? So, when I go to my 4th level of Pascal's, okay, and if you go back and look at it, when I see x to the 4th, all right, I'm going to this level where it says 4, because it goes 0. So these are the coefficients that I'm going to write out to start, okay? So for the 4, I'm going to write out 1, I'm going to write out 4, I'm going to write out 6, I'm going to write out 4, and I'm going to write out 1. Okay? All right. The second component of what I'm going to do is what we just worked on with the variables. Okay? So this is going to be, and I'm going to use the parentheses, and I'll explain why in a little bit, x4, y0 to start. Okay? So then what's going to happen next? x3, y1, and then I'm going to go x2, y2. Then I'm going to go x1. Oh, whoops, I'm sorry, I'm writing that incorrectly. Hold on. Let's go back. Sorry. I would go 4y to the 1st plus 6 x2 y2. Then I'm going to go 4 x1 y3, and then I'm going to go 1 x 0 y4. How do I know I'm done? I know I'm done when I get all the way to 4, okay? Now, here's the deal. What does that mean for me? The ones with the zeros, I can go ahead and just cross off. I know those won't matter, okay? So, x to the 4th, 1x to the 4th. This will matter later when we actually do number calculations, but this will be 4x cubed, y to the 1st. This would be 6x squared, y squared. This would be 4x1, y cubed. And this would be 1 y to the 4th. So I just expanded that using those two principles that we were just talking about. Okay? Let me do one more with you. Okay? Let's say I was doing x plus y to the, let's say to the 8th power. Okay? So, what I would start with, all right, I would have 1, I'd have 8, I'd have 28, I'd have 56, I'd have 70, I'd have 56, I'd have 28, I'd have 8. Let's not do that there. Let's do that down here. I have 8, but I have 1. Okay? Now, from an exponent standpoint, okay, I'd have x8, y0. I'd have x7, y1. I'd have x6, y2. I'd have x5, y3. I'd have x4, y4. I'd have x3, y5. I'd have x2, y6. Okay? I'd have x1, y7. And then I'd have x0, y8. How do I know I'm done? I know I'm done when this one becomes 8. So I cross off those zeros, cross off that 0. So what does this mean for me? This would be 1x to the 8th plus 8x7y plus 28x6y squared plus 56x5y3 plus 70x4y4 plus 56x3y5 plus 28x squared y6 plus 8x to the first y to the 7th, and the last part would be plus 1 y to the 8th. And that is an expansion of those basic things, okay? So what I would like you guys to do, okay, what I like you guys to do is I would like you to try to just do the basic expansion of x plus y to the 5th, and let's do x plus y to the 9th. Okay, so go ahead and pause your video and go ahead and work on those. Okay, go ahead and unpause. I'm going to go through that with you. Okay, all right, x plus y to the 5th. Okay, all right, let's start with Pascal's. The fifth one would be 1 plus 5 plus 10 plus 10. No, 1, yes, plus 10 plus 5 plus 1. Okay? All right? So, what I got here, okay, now I got to work the exponent part. So, x5, y0, okay, x4, y1, x3, y2, x2, y3, x1, whoops, 1 should be up there, y4, x0, y the 5th. Okay? So, what does that mean for me? First one would be 1x to the 5th. Go ahead and cross off the ones with the zeros. Okay? All right, then I got 5x4, y1. I got 10x cubed, y squared. I got 10x squared, y cubed. I got 5x to the first, y4, plus 1 y to the 5th. Okay? So that's the expansion of that one. Okay? All right. All right, let's go ahead and do that second one. All right? I'm going to do x plus y to the 9th. Okay? So let's go to Pascal. What does that mean? I'd have 1, I'd have 9, I'd have 36, I'd have 84, I'd have 126, I'd have 126, I'd have 84, I'd have 36, I'd have 9, and I'd have 1. Okay, all right. So, what is this going to start with? X to the 9th, y to the 0, and it's going to go x 8, y 1, then x 7, y 2, then it's going to go x 6, y 3, then x 5, y 4, then x 4, y 5, then x 3, y 6, okay? Then x 2, y 7, then x 1, y 8, and then x 0, y 9. How do I know that I'm right? Because I know when I get to the end that it's got to be the 0. So let's cross off the 0 parts. Okay, so this would be 1x to the 9th plus 9ix 8y1, 36 x7 y2, 84 x6 y3, 126 x5 y4, 126 x4 y5, 84 x cubed y6, 36 x squared y7, 9x y8 plus y to the 9th, 1 y to the 9th. Okay, so that's the expansion. Okay, hopefully you can see that on your screen. Okay, now let's talk about, and probably what we'll finish with this video, is what happens when you start injecting numbers, all right, in for the terms. Okay, so let's say I want to do x plus 2y to the 4th power. Okay, now it's the same concept of what you want to start with. So I want to start with Pascal's 4th row that would say 1, that would say 4, that would say 6, that would say 4, that would say 1. Okay? All right? Now, here's the difference. Okay? When I do this, okay, I'm going to start with x4, and then for my other term, I actually have to put that number in there. Okay? So that's going to be there. Then I'm going x3, 2y to the 1st, then x2, 2y to the 2nd, and then I got x 1, 2y to the 3rd, and then I got 1x to the 0, 2y to the 4th power. Okay, now, from a number standpoint, okay, from a number standpoint, what I want to do, first of all, the zeros don't matter. Okay, so this is pretty easy. This first one will be 1x to the 4th. Not a problem there. From the number standpoint, I want to put them into the calculator just like I see them. Okay, now, I didn't have to worry about this one because it didn't have a number in there. All right, so this actually would be 8. So 8x cubed y to the 1st. Okay, now this one, I would do 6 parentheses 2 to the 2nd. That is actually going to be 24 x squared y squared. So that's how you figure out the numbers. The parentheses will be vital, especially when we get to the negatives. Okay, this one would be 4, okay, 2 to the 3rd power. That's going to be 32 x1 y cubed. Okay, and then the last one here, okay, would be a 1, 2 to the 4th power. That's going to be 16 y4. And that's the expansion. That's how Pascal's thing can help you expand that instead of having to FOIL it. Okay, let's do another example. Okay, let's do another example. Let's say I got 3x plus 5y to the 6th power. Like, oh boy, like that would be a lot. Okay, now what you got to do, start with Pascal's, in this case, 6th row. The 6th row would be 1, it would be 6, it would be 15, it would be 20, it would be 15, it would be 6, and it would be 1. Okay? Now, I would start with 3x to the 6th, 5y to the 0. 3x to the fifth, 5y to the fourth. No, sorry, first. Okay, then 3x to the fourth, 5y squared. Then 3x to the third, 5y to the third. Then 3x to the second, 5y to the fourth. Then 3x to the first, 5y to the fifth. And then 3x to the 0, 5y to the sixth. Okay, now I would put the plus signs in between so I did not get confused. I'll do that when we do the notes, okay, which terms are what. So what you got to do, we know the 0 ones go away. Let's just get rid of those right off the bat. So what this would be, okay, is 1 parentheses 3 to the sixth. That's 729. So it's 729 x6. All right. What's the next term? All right. I would have to do, all right, 6 times 3 to the fifth, 5 to the first. Okay. 7290 x5 y1. Then I would do 5 times 3, okay, to the fourth, 5 to the square. 10,125. x4, y2. Go to the next one. Okay, I got 20, all right, parentheses 3, okay, and then 5, 3. All right, 67,500. x3, y3. Then I go to the next one. 15, 3 to the second, 5 to the fourth. 84,375, x squared, y4. Then I go to the next one. All right, 6, 3 to the first, 5 to the fifth. 56,250. x1, y5. Okay, and then I got 1 times just 5 to the sixth power. 15,625. Okay, so that's how Pascal's triangle can help you go ahead and expand those. It's sort of crazy. Okay, so what I'd like you guys to do, okay, is try on your own. Try on your own. X plus 4y to the, let's go to the fifth. And let's do, I'd also like you to try 4x plus 2y to the, let's say to the sixth power. Okay, go ahead and try those on your own. I will put the notes. My video is running out here. I will put these in the notes online.